Welcome to Hinkley Point C, where over 9,000 men and women are working feverishly to get this plant online as quickly as possible to support net zero. Let me start our tour by taking you to the Reactive pressure vessel temporary building. The Reactive pressure vessel, which is 13 metres long, will actually produce the energy through fission to produce the heat for our turbines that will produce electricity for over 3 million homes. The Reactive pressure vessel itself was delivered earlier this year by our partners Framatome, and let's go and look now where it's going to be introduced into the plant. We can see a great view here of Unit 1's nuclear island, and that equipment hatch that RPV we've just looked at will go through. We're up to level 9 of the internal containment concrete and level 5 of the external. The building itself is 43 metres high since we've added the extra ring from our last video in June. Behind me here, we've actually stacked the domes on top of each other. So this is Unit 1 and Unit 2's dome. But one of them domes will actually go on by the end of this year on top of the containment you can see there to complete the building. Let's go and look inside. So welcome to Unit 1's nuclear island. You can see the great progress we've made on the civil structures. These internal structures will house all the key components. Behind us you can also see we've introduced the reactor cavity pool and the large storage pool behind it. Above us you can see the 45 polar crane brackets. Polar crane itself is being built in a structure just across the road from where we are today. In here we're actually stood on the 19.5 level, which will be the working platform for the nuclear island. Looking forward for the rest of 2023. The key activities are to fit the reactor support ring, which the actual reactor pressure vessel will sit in, fit the equipment hatch that will allow us to seal this big containment equipment hatch hole, and then fit the polar crane. And they're the key steps then to actually fit in the dome for Unit 1. Once we've actually fitted the dome, we're able to start introducing the key reactor components here that will allow us to generate heat and actually produce steam for our turbine. Let's go and visit the turbine hall. Welcome to Unit 1's turbine hall, which will house the largest turbine in the world. Last time we were here in June, the blue columns were covered with falsework. You can now see them fully exposed. You can also see the cream structural steelwork. There's 10,700 tonnes of steel to be fitted. That will allow us then to fit the 300-tonne crane, which will actually support operations, maintenance and installation of the turbine. We've already fitted one crane here for the main feed pumps. And behind us also you can see the electrical building where our mechanical, electrical and HVAC colleagues are busily working to make sure that we're in good shape for commissioning. Our plan is to hand this area over to General Electric, our turbine partner, before the end of this year. So that completes our journey above ground. Now let's go underground. So here we are in the heat sink of Unit 1, 30 metres under the ground. To the side of me here is the biggest civil structure on the power plant, the pump house. This year so far we've poured 3,000 cubic metres of concrete, and you can see the building is actually now above the ground. Eventually this building will receive millions of tonnes of seawater that will go into our condensers that turn the steam that turns the turbine back to water to allow it to be reintroduced into the steam generators. So this is Unit 1's inlet tunnel. It stretches out 3.2 kilometres out to sea. At the moment we're fitting the big bulkhead door and the ring propping system that will allow us to do the tunnel shaft connection. Last year we fitted the 5,000 tonne inlet heads, and since then we've actually put the rock armour that will stop scouring around them. We're really looking forward to the marine works progressing even further this year. We're beginning by using 2 huge jack-up vessels to install 6 vertical shafts, each over 20 metres deep. This will connect the heads with the tunnels themselves, allowing seawater to pass through. So for the remainder of 2023, the important milestones for us is to really mobilise our mechanical and electrical HVAC partners into the pump house to start installing the pumps and cables and cable tray that we need to bring the building to life to support flooding this forebay in 2025. Let's go back above ground. We've just come from Unit 1's heatsink and we're here on top of Bunker 6. Here we get a great view of the progress made across the whole of the site. In Bunker 6 here, liner ring 2 is nearly complete and will be lifted out in April to be painted and eventually put onto Unit 2. So great progress. Here on Unit 2, which was most impacted by the COVID pandemic, we're seeing productivity improvements of 20 to 30%. This is really important to allow us to catch up on Unit 2, but also for our sister plant at Sizewell, where we can take them improvements and perhaps even improve on them even more. I hope you've enjoyed the tour today. I look forward to seeing you again. Thank you.